Introduction: An outline development process and use cases. Introduction: Following topics are thrown importance in this chapter. What is the UML? How we got here? Notations and meta models. Why do analysis and design? Overview of the process. Inception. Elaboration. Planning the construction phase. Construction. Transition. When to use iterative development. Use case diagrams. Business and system use cases. And when to use cases. What is the UML? The Unified Modeling Language is a family of graphical notations. It is backed by single meta model, which the UML helps in describing and designing software systems, particularly software systems built using the object-oriented style. The UML is controlled by the Object Management Group, an open consortium of companies. The UML is a relatively open standard. The OMG is originated to build standards that supported interoperability, exclusively the interoperability of object-oriented systems. The OMG is best known for the CORBA, Common Object Request Broker Architecture Standards. Unification of many object-oriented graphical modeling languages is the ancestors of the UML. This unification thrived between in the late 1980s and the early 1990s. How we got here. Literature of the subject. In the 1980s, objects shifted to be away from the research labs and took their maiden stride towards the real world. C++ was born due to the Smalltalk stabilization into a platform. Meanwhile, various people started to work on object-oriented graphical design languages. The key books about object-oriented graphical modeling languages appeared between 1988 and 1992. In spite of being very similar, methods in these books contain a number of often annoying minor differences among them. The same basic concept would appear in a disagreed way, created confusion to my clients. Grady and Jim had prepared their first public description of their merge method by OOP-SLA 95, version 0.8 of the Unified Method documentation. The next year saw the shift from passive position of OMG to be an active, which had mostly stood on the sidelines. The vendors energized the OMG to do something under the banner of case tool interoperability. The idea was to create a UML that would allow case tools for free exchange models. Various organizations submitted proposals for a method standard to facilitate the interchange of models in January 1997. Rational collaborated with a number of other organizations and released version 1.0 of the UML documentation. The OMG adapted the resulting 1.1 as an official OMG standard. Revision 1.2 was entirely cosmetic. Revision 1.3 was more significant. Revision 1.4 added a number of detailed concepts around components and profiles. Revision 1.5 added action semantics, notations and meta models. The UML in its current state defines a notation and a meta model. The notation is the graphically stuffed in models, for it is the graphical syntax of the modeling language. The idea of rigorous specification and design languages is most predominant in the field of formal methods. Most graphical modeling languages have no rigor. Their notation appeals to intuition rather than to formal definition. To improve the rigor of methods, Without sacrificing their usefulness, we can define a meta model. A diagram, usually a class diagram, that defines the concept of the language. Why do analysis and design? Software development holds its real point in cutting the code. We will discuss the reasons for using UML and let's see how it reflects in writing the code. Communication. The fundamental reason to use the UML involves communication. Use the UML when you want a certain amount of precision but you don't want to get lost in details. Use it to highlight important details. It helps to acquire an overall view of the system. A class diagram can tell what kinds of abstractions are present in the system and where the questionable parts need further work. Interaction diagrams illustrate key behaviors in the system. To build a roadmap of a large system, use package diagrams to show the major parts of a system and their interdependencies. For each package, draw a class diagram. Use patterns to describe the important ideas in the system that appears in multiple places. Learning object-oriented. Though the techniques in the UML were designed to help people do good object-oriented, different techniques have different advantages. One of the most valuable techniques for learning object-oriented is CRC cards. They were designed primarily for teaching people to work with objects. As such, CRC cards are deliberately different from traditional design techniques. CRC cards become particularly valuable when their emphasis on responsibilities and their lack of complex notation. As interaction diagrams make the message structure very explicit, they are useful for highlighting over-centralized designs in which single object is doing the whole work. Class diagrams are both good and bad for learning models. They are used to illustrate class models. It is easy to develop a class model that is data-oriented rather than being responsibility-oriented, which is a major problem of using it. The concept of patterns has become vital to learning object-oriented because using patterns gets you to concentrate on good object-oriented designs and to learn by following an example. Another important technique is iterative development. This technique does not help you to learn object-oriented in any direct way, but it is the key to exploiting object-oriented effectively. If you do iterative development from the start, you will learn in context the right kind of process and begin to see why designers suggest doing things the way they do. Communicating with domain experts. The biggest challenge faced in development is that of building the right system, one that meets user needs at a reasonable cost. The technique to be used to address this issue is use cases. A use case is a snapshot of one of the aspects of your system. The sum of all use cases is the external picture of your system, which will explain what the system will do. A good collection of use cases is central to understand what your users want. As use cases control iterative development, which is a valuable technique, they present a good vehicle for project planning. Class diagrams can be used to look at the deeper things. Activity diagrams are very useful in cases in which workflow process are an important part of the user's world. These diagrams de-emphasize the links to classes. Though de-emphasizing can be a problem in later design, it becomes an advantage during this more conceptual stage of the development process. Overview of the process. This process is an iterative and incremental development process in which the software is developed and released in pieces. The construction phase consists of many iterations in which each iteration builds production quality software tested and integrated that satisfies a subset of the requirements of the project. Each iteration contains all the usual life cycle phases of analysis, design, implementation, and testing. During inception, you establish the business rationale for the project and decide on the scope of the project. In elaboration, you collect more detailed requirements, do high level analysis and design to establish baseline architecture and create the plan for construction. The transition phase includes beta testing, performance tuning, and user training. Inception and elaboration. Inception. During the inception phase, you work out the business case for the project, roughly how much it will cost and how much it will bring in, and get a sense of the project scope. Inception should be a few days' work to consider whether worth of a few months. Work in deeper investigation during elaboration. Elaboration. At this point, you want to get a better understanding of the problem. What is it you are actually going to build? How are you going to build it? While deciding what issues to be given priority in this phase, you must be aware of the risk. Risk can be usually be classified into 4 categories. Requirement risk. What are the requirements of the system? The big danger is that building the wrong system does not fulfill the customer needs. Technological risk. What are the technological risks one has to face? Do you select technology that will actually work for you? Will the various pieces fit together? Skills risk. Are the sources like the staff and expertise available? Political risk. Are there political forces that can interfere in the way and seriously affect your project? Elaboration. Dealing with requirement risk. A use case is a typical interaction in order to achieve a goal a user has with the system. Use cases provide the basis of communication between customers and developers in planning the project. An essential part is to discover all the potential use cases for the system you are building in the elaboration phase. Another important task is to come up with the skeleton of a conceptual model of the domain. Techniques in building conceptual domain models. Use class diagram drawn from a conceptual perspective. Class diagrams are about defining a rigorous vocabulary to talk about the domain. Describe a domain with a strong workflow element using activity diagrams. Interaction diagrams are used to explore how various roles interact in the business. Prototyping is a valuable technique for getting a better understanding of how more dynamic situations work. Dealing with technological risk. Addressing technological risk is to build prototypes that try out the pieces of technology you have an idea of using. The biggest technological risks are inherent and how the components of a design fit together rather than being present in any of the components themselves. It is very important to get all the components you intend to use and fit them together at this early stage of the process. Address any architectural design decisions during the technological stage. Focus on any areas that look if an issue seems to be difficult to change later, focus on those areas. As with the domain model, you should look at the use cases as they appear in order to assess whether they contain anything that could cripple your design. Use a number of UML techniques to jot down your ideas and document the things you try. Class diagrams and interaction diagrams are useful in showing how components communicate. Package diagrams can show a high-level picture of the components at this stage. Deployment diagrams can provide an overview of how pieces are distributed. Dealing with skills risk. Since instructors have already made those mistakes, training is a way to avoid making mistakes. Though an overview of people's need is meted out, they don't really pass on the core skills that you need to do a serious project. Get your training in small chunks when you need it. Acquiring object-oriented skills through mentoring is the best way in which you have an experienced developer work with your project for an extended period of time. The mentor shows you how to do things, watches what you do, and passes on tips and short bits of training. Your mentor will work with the specifics of your project and knows which bits of expertise to apply at the right time. You can also supplement your skills by reading a solid technical book at least once every other month. Construction. Construction builds a system in a series of iterations. Each iteration is a mini project. The iterations within construction are both incremental and iterative. The iterations are incremental in function. Each iteration builds on the use cases based on the development of the previous iterations. The iterations are iterative in terms of the code base. Iteration each involves rewriting some existing code to make it more flexible. Refactoring is a highly useful technique in iterating the code. You do not need to change the functionality of your program while refactoring. Instead, you change its internal structure in order to make it easier to understand and work with. It is a good idea to keep an eye on the amount of code thrown away in iteration. A developer should integrate after every significant piece of work. Integration should be a consistent process. Iterative development is time boxed, which is its key factor that you are not allowed to slip any dates. But use cases can be moved to a later iteration via negotiation and agreement with the customer. Using the UML in construction. All UML techniques are useful during this stage. A conceptual class diagram can be useful to figure out some concept for the use case and see how these concepts fit with the already existing software. CRC cards and interaction diagrams are useful in exploring how the classes will collaborate to implement the functionality required by each use case. What you have done can be documented with the help of UML. Use a package diagram as logical roadmap of the system. A deployment diagram shows the high-level physical picture. Use a specification perspective class diagram within each package. A class with complex lifecycle behavior can be better described by drawing a state diagram. If a particularly complex algorithm is involved, use an activity diagram. Use patterns to capture the basic ideas. Transition. In order to improve performance, the clarity and extensibility of the system are reduced by optimization in order to improve performance. On the other hand, earlier optimizing makes development tougher, so this is one thing that needs to be left to the end. During transition, there is no development to add functionality unless it is small and absolutely essential. There is development to fix bugs. Example, time between the beta release and the final release of a product. When to use iterative development? We can use iterative model in the following cases. Requirements of the complete system are clearly defined and understood. When the project is big, though some details can evolve with time, major requirements must be defined. Some details can evolve with time. Advantages of iterative model. We can only create a high-level design of the application prior to build the product and define the design solution for the entire product. In the later period, we can design and build a skeleton version of that and evolve the design based on what had already been built. As we are building and improving the product gradually, we can track the defects in the earlier stages. This avoids the downward flow of the defects. We can get the reliable user feedback when presenting sketches and blueprints of the product to users for their feedback. We are effectively asking them to imagine how the product will work. Less time is spent on documenting and more time is given for designing. Disadvantages of iterative model. Each phase of iteration is rigid with no overlaps. Costly system architecture or design issues may arise because not all requirements are gathered upfront for the entire life cycle. Use case diagrams. Actors. An actor is a role played by a user with respect to the system. There are 4 actors in previous figure, namely trading manager, trader, salesperson, and accounting system. Though there are many traders in the given organization, they all play the same role. A user may also play more than one role. It is important to think about roles rather than people or job title while dealing with actors. Actors carry out use cases. A single actor may perform many use cases. A use case may have several actors performing it. An actor can also be an external system that needs some information from the current system. There are some situations in which it can be worth tracking the actors later. The system may need configuring for various kinds of users. In this case, each kind of user is an actor and the use cases show you what each actor needs to do. Tracking who wants use cases can help you negotiate priorities among various actors. A good source for identifying use cases is external events. Use case relationship. There are several kinds of relationship between use cases. They include relationship occurs when you have a chunk of behavior that is similar across more than one use case and you don't want to keep copying the description of that behavior. When you have one use case that is similar to another use case but does a bit more than the other. Use case generalization. This gives us another way of capturing alternative scenarios. There are more rules in extend, however, it is similar to generalization. A use case may have many extension points and an extending use case may extend one or more of these extension points. If you want to avoid repetition, use include. Use generalization when you are describing a variation on normal behavior and you wish to describe it casually. Use extend when describing a variation on normal behavior. In the meantime, use the more controlled form, declaring your extension points in your base use case. Business and system use cases. A common problem that can happen with use cases is that by focusing on the interaction between a user and the system, you can neglect situations in which a change to a business process may be the best way to deal with the problem. A system use case has an interaction with the software. How a business responds to a customer or an event is discussed by a business use case. System use cases are more useful for planning. Business use cases are used to consider other ways to meet an actor's goal. You need at least one set of system use cases for each business use case by end of elaboration phase. When to use cases. Use cases are an essential tool for the requirement of capturing, planning, and controlling an iterative project. Capturing use cases is one of the primary tasks of the elaboration phase. Every use case is a potential requirement. Until you have captured a requirement, you cannot have a plan to deal with it. Conceptual modeling with users helps uncover use cases. An external view of the system is represented by use cases. Don't expect any correlations between use cases and the classes